So now let's talk about simple interest. When I talk about interest, what I'm talking about is a fee that's paid for using money. You owe interest when you borrow. And instead you earn interest when you invest. And we're going to find, as we're looking at interest, we use a lot of formulas. So I'd like to show you how I want you to use the formulas. But going back to interest, interest is usually expressed as a percent. So different types of interest. When I look at simple interest, we use an uppercase I to equal the interest amount, the dollar amount of the interest. We use the R to represent the rate, and it's usually a percent. But we have to express it as a decimal. T is the time, and it needs to be expressed in years. And P is the principal, which is the starting amount. It can be the loan amount or the original investment. And the formula that we use for simple interest is I equals P R T. When you solve an interest problem, I ask that you first write the formula, that you're using. And second, I ask you to identify your variables. Third, I ask that you show your substitution. And then I ask that you show your final answer. For most of these, you'll mostly be typing your values into a calculator, a scientific calculator. And so if you want to get any partial credit for your work, you must do these to show your work. So let's look at some examples. For our first example, let's say we borrow, let's say $2,400 for 2 years at 7% annual simple interest. Well, and we want to find the interest earned. My formula is I equals P R T. P is my beginning amount, which is that $2,400. R is my interest rate, 7%, but I have to write that as a decimal, 0.07. T is my time in years, which is 2. So I get I equals 2,400 times 0.07 times 2. And using my calculator, I get $336. Let's look at a couple more examples. This time, let's say we invest $10,000 at 5% simple interest for 8 months. And we want to find the interest earned. Oh, up here, this shouldn't say earned. This should have said, oh, sorry about that. It's a loan. So, the formula is I equals PRT. P this time is our initial investment, $10,000. Our rate is 5%, which is 0.05. But here, our time is 8, not years, but months. We want to write that as a year. So I'm going to change that into a fraction, 8/12. I strongly suggest that you leave as a fraction, because sometimes if you round, change it to a decimal, you have to round, and that gives you errors. You can reduce the fraction, but if you're just typing it into your calculator, there's no need. So here I get I equals my principal, 10,000, times my rate, 0.05, times my time, which is the fraction 8/12. And I'll enter that in my calculator as 8 divided by 12. And we want to find to the nearest cent. And so when I multiply that out to the nearest cent, I get $333.33. Next example. This time, let's say we borrow $1,000 at 6.5% interest for 60 days. We want to find the interest owed. Well, this one has a couple of things going on. First of all, again, we don't have years, we have days. And so what happens with these is we usually use a banker's year, which is 360 days. So how does that apply? If my formula is I equals PRT, P is my $1,000, R is my 6.5%, which is 0.065, T is 60 days, but again I have to change that into years, so that would be 60 over 360 years. So when I type this in, when I substitute first, P is 1,000, R is 0.065, and T is 60 over 360. And when I multiply all of those, I get that the interest was $10.83. Next, we're going to look at the future value of something. And the future value is the principal plus the interest. And so when I look at future value, an uppercase A is frequently used to represent future value. Now, A is equal to the principal plus the interest, and we can use that, but a lot of times we look at that interest as the principal times the rate times the time. And so from that, if I think of undoing distribution, that gives me the principal times 1 plus RT. And so this is the formula that we'll use for future value with simple interest. So, how does that one work? Let's look at an example. Let's say I invest $2,040 at 7.5% simple interest for 4 years. What's its future value? Well, since I'm looking for the future value, I'll use the future value formula. A equals P times the number 1 plus RT. Identifying my variables. P is the beginning $20,040. The rate is 7.5%, but I need to change that to a decimal, 0.075, and my time is 4 years. So I get A equals 2,040 times parentheses 1 plus 0.075 times 4. And if you enter this in your calculator, you can do it all at once. You just have to make sure that you use your parentheses keys. So that gives me, I would type that all in and get $2,652. If I look at another example, let's say this time I know that I need $2,150 in a year. I have $2,000. What rate do I need to invest at? Well, this time that 2,150 is not what I have now, but rather what I want in the future. So that's going to be my future value. So I'm going to use my future value, A equals P times 1 plus RT. The future value is the 2,150. The principal of present value is 2,000. The time is 1 year. And the rate is what we're looking for. Substituting, it gives me 2,150 is equal to 2,000 times 1 plus r times 1. Now, to solve this, the first thing I need to do is distribute, or multiply everything in the parentheses by that 2,000. That gives me 2,150 is equal to 2,000 plus 2,000r. To solve, we want to isolate the variable, get the part with the r alone first. So I'll subtract 2,000 from both sides. And I'll get 150 is equal to 2,000r. And then finally, to solve, I'll divide both sides by 2,000. Doing that division, I'll get r is equal to 0.075. This time I want to change that into my percent. My rate would have to be 7.5%. One more example. This time, let's say I need $6,000 in 4 years. How much should I invest now? At 8% interest. And again, that $6,000 is what I want in the future. It's in 4 years. So I'm going to use my future value formula. A equals P times 1 plus RT. A is at $6,000. P is what we don't know. R is 8%. Don't forget to change that to a decimal, 0.08. And T here is 4 years. This time when I substitute, I get 6,000 is equal to P times 1 plus 0.08 times 4. And here, with this one, I can simplify what's in the parentheses, and that gives me 6,000 is equal to 1.32 P. And to solve, I'm going to divide both sides by 1.32, which gives me P equals 4545.4545. Putting it all down, because with these we're going to always round up to find P. So I'm going to say that I need $4,546 to the nearest dollar. We round up because if we were not to round up and just use traditional rounding rules, we would not have enough money at the end.